Okay, good morning or good afternoon, I suppose. Hopefully everyone had a nice long weekend. I had last week, if we go backwards to the last class that we were together was last Thursday. And I had asked you to work on the percentile rank assignment and the end of the unit, right? So percentile rank. Again, a ranking is just an ordering of the class members or the group members. It has nothing to do with your actual mark. It just tells where you rank your order in the group. So I didn't receive any questions, or like maybe someone can chime in if they have any questions on assignment 4. But if not, I thought I would go through the review with you. There are 10 questions on the review assignment, and I know some of you have already requested the test, so this may not be useful to you. And if that's the case, then you can just, I guess, have the... Okay, Tim, I got your message. How about I do that after class? Is that okay? Hi, Tim. I'll email you after class today then. So I'm going to continue on. I thought what I would do is just go through some questions on the unit review. Maybe not all of them, and just make sure everyone's ready for the test. And once you're comfortable, you can request a statistic to you, and then you can just email your results back. And then we are going to begin our next unit, which will be the probability unit. We've got probability and precision to get through, and if we don't make it through precision measurement, it's not a huge deal. Hi, Cynthia. But we'll, Cynthia, I'm going to be going through the stats unit review, so it's probably not that interesting for you since you already wrote your test. But I'm going to go through a few questions anyway, just for the rest of the group. So the first topic that we did was the mean, median, mode, right? And so you should have an understanding of what those are. So for the data below, find the mean, median, mode, round to 1 decimal if necessary. So let's do that. Let's do number 1. Okay, so the mean, how we calculate the mean is we just add up all the values. So I'm going to subtotal those, and then I'm going to divide by how many values there are. 1, 2, 3, 4, 5, 6, 7. Okay, so let's see what we get here. Let's go take my calculator. So I get 51 as a total, a subtotal, divided by 7. Remember, our default is always to round to 2 decimals if we have to round. So this would be the mean. That's how you calculate the mean. You just subtotal all the values and divide by the number of values. N is not a calculation as so much as an ordering. So I order the values from small to large. So the smallest value is a 5. Okay, and then I have a 6. So I have a 5 and a 6 and a 7. And 2 8s. I have to include both of them. Or sorry, 3 8s and a 9. 1, 2, 3, 4, 5, 6, 7. Okay, and now I just find the value that's in the middle of the set. So these two are the ends, and then these two pair, these two pair. So my middle value is an 8. So the median is 8. They're both measuring the values of the data, like trying to give you an idea of what the data is representing. So we've got a mean of 7.29, a median of 8. Sometimes these are the same. And then the mode is the most common, the most frequent. So the mode would be 8 because there's 3 of them, right? The most common value is 8. Oh, thanks, Cynthia. So to 1 decimal place, it would be 7.3 for the back of the book. It's great if your data has all 3 of these matching. It means your data is really consistent. And let's see. I won't do this one. It's the same type. Explain why the mode might not be a good descriptor. Well, the mode would be 22. And the 22 seem to be outliers, right? They're not really representative of the data. That's what I would say. Explain why the mean might not be a good center for the group. Let's see. 1, 2, 3, 4, 5, 6, 7. They're all in order. So these 2 pair off, these 2 pair off, these 2 pair off 85. I guess 85, if I consider that these 2 are valid and not outliers, it kind of, the 85 as a median or a mean would not be representing the zeros. But to be honest, I think I might agree with 85 being a mean and labeling the zeros as outliers. Statistics are very open to subjectivity, meaning you can kind of make things mean what you want them to mean a lot. Okay, let's try number 5. I'm just going to kind of buzz down to number 5 because it's talking about trimmed means. Now, trimmed means address the exact problem I was just talking about. Like, for example, in this group, the group I was just referencing, you got a couple of zeros in here, right, that don't really seem to fit the data. I might want to trim these zeros out, just get rid of them, which is okay. I can get rid of these 2 zeros, but if I get rid of 2 of the lowest scores, I have to get rid of 2 of the highest scores just to keep things even. And that's what they call a trimmed mean. And that happens, and it's very advisable if you've got some data that just doesn't seem to belong. And sometimes that happens in a group of data. You get an outlier. Sometimes it's because you collected the data wrong or you recorded the wrong number. You accidentally wrote a wrong number down. So you can get rid of that as long as you get rid of 1 on the other end. All right, find the mean of this data. 6.1 and 8.2 and 8.3 and 8.5 and 8.7 and 9.8. 1, 2, 3, 4, 5, 6. I should have 6 numbers. Yep, I do. I'm going to subtotal those in a minute. And I'm going to divide by 6. All right, so what do I get here? Oops. I get 49.6 divided by 6. So I get 8.3. I'll just round it to 1 decimal again. Okay, so that's my mean. Now it's saying trim the top and the bottom scores. So I have to make sure they're in order. Small, and then the next one. Yeah, so they're all in order. So if I trim the top and the bottom means, what that's going to do for me, it's going to reduce my numbers to, I'm just going to have 8.2 and 8.3 and 8.5 and 8.7. And I'm going to be dividing by 4 instead of 6, right? If I've trimmed 2 of the numbers off, so I get 33.7 divided by 4, and that will give me 8.4. So it slightly adjusts the mean, right? It brings the mean up a little bit. All right, now it says, find the trimmed mean if 2 of the scores are removed. So if I remove the 2 lowest scores, I have to remove the 2 highest scores. And that just leaves me with 8.3 and 8.5. So I'm just going to be dividing by 2 this time. And I know that the middle of 8.3 and 8.5 is going to be 8.4. So really, trimming 2 values doesn't change the the trimmed mean from part B. So it really was that part A, the crucial step, just removing the bottom, the lowest value and the highest value, right? Let's try number 6, because that is actually a weighted mean. I'll do number 6 as well. So let's read the words for number 6 first, and then I'll show you my work. So number 6 says, a final grade is calculated using a weight of 10% for assignments, 60% for tests, and 30% for the final. Neil got 94 on assignments, 81 on tests, and 65 on the final. Calculate his final grade for the course. This is a weighted mean, meaning there's categories that they divided the data into, and each category has a different weight. And this is frequently found in schools because typically there's more weight put on an exam and there's more weight put on tests than assignments. So let's find his weighted mean. So let's try this, number 6. Move this up a bit. Okay. So how I calculate the weighted mean is I take the score, he got 94% on assignments, and I multiply by the weight for assignments. And then I add the next score. The next score was 81, and the weight was 60 for tests. Okay, this is the weight, right? This is the score, weight. And then the last score, he got 65 on the exam, and the weight was 30, okay? And the reason I kind of double underlined the weights is the bottom, the denominator of this fraction is the sum of the weights. So 10 and 60 and 30. Okay, so I've got subtotaling to do on the top, subtotaling on the bottom. Let's see what happens here. Okay, so I get a subtotal of 77.50, and the bottom is 100. I added those up. So that's going to give me 77.5 is his mark, right? And that would be percent, 77.5%. And that was just taking into account that the different categories meant had different levels of importance, right? All right, let's try number 7. People who want to become police officers have to take 2 tests, an academic and a physical. That makes sense. Serena scored 250 out of 30 on her physical and 23 out of 40 on her academic. Calculate Serena's mean score if the tests are weighted evenly, the physical test is weighted at 75%, and the academic is weighted at 25%. Okay, so this is, just going to get a new paper. Number 7. The problem with this one is that you can lose is they're asking, or they're telling us that the categories are weighted as percents. So what you have to remember is first, we must convert her raw scores into percents. Okay, so first we have to score on the physical test. The physical, we'll call it. She got 250 out of 300. So to convert that to percent, remember, it's telling you to do the division. And just to convert to percent, we just have to multiply by 100. Okay, so I get 83.33, repeating, but I'm just going to use 2 decimals. And then her academic, whoops, I can spell that wrong. She got 23 out of 40. Okay, it's hard to figure out if that's good or bad till I multiply it by 100, till I do the division, multiplied by, 23 divided by 40, multiplied by 100. She has 57.5% on her. So now at least it looks like she's done way better on the physical, right, than the academic. So now at least I have my scores, right? Now, the tests are weighted evenly. That means they're equal. So that's just a regular, that's just calculating the normal mean, right? I just add them up and I divide by the number. That's just the regular mean. When it says weighted evenly, just the regular mean. So we get 70.4. They probably used one decimal in the back, so I'll just leave it as one decimal. She'll get a 70.4. That's just the regular mean. Now let's do the weighted. Okay, so the weights are different. They're saying weighted, physical 75, academic 25. I think she's going to do better this way if they weight the mean heavier on the physical, because she scored so much better on the physical than the academic. If they regard this as more important, her mark should go up. So let's see what happens. I take the score and I multiply by the weight. And I'm just going to double underline the weight again to make sure that that's the number I include in the bottom. Plus 57.5 multiplied by the weight. Okay, now I'm going to add up the weights. Once again, I get 100. Now what do I get on the top? Okay, so on the top I get 7, 8, oops, sorry. I read my calculator wrong. 7, 6.25 divided by 100. And that's going to give me 76.9, I guess. And sure enough, look how much better. This is the weighted mean. So it really works out if you, a weighted mean, if the category that you're strong is weighted heavier, right? So her mean jumped from 70 to like 77. That's quite a significant difference. That shows you how weighted means operate, right? And why they're used, because some categories are deemed more valuable or more important. And maybe for this particular police force, they're valuing physical strength over mental strength. Let's try, if I was doing the mean, I'm just going to explain number 8 for you. Number 8, if I have the weight. Okay. So you would just multiply 50 times 3 plus 60 times 5 plus 70 times 9 plus 80 times 7 plus 90 times 2. I suppose I could have just done that, right? Maybe I'll just do that. So 50 times 3 plus the score. So this has to be the weight. $80 times 7 plus 90 times 2, all divided by, okay, the sum of the weights. So I add this up, 3 plus 5 plus 9 plus 7 plus 2. Okay, so I'm going to get a big number on top, really big number. 70 times 9, 80 times 7. I get 1820 on top divided by 26. And that's going to be equal to 70. So if you get frequency is just another weight, another name for weight. It's the relevance, right? Obviously, a frequency of 9 is going to be way more important than a frequency of 2. All right, let's talk about our last topic in this unit, and it's percentile rank. So there's 4 main topics. It's the mean, median, and mode. It's the trimmed mean and the weighted mean, and then percentile rank. That's it. There's 4 main topics in this unit. At a music competition, contestants received scores out of 50. 14 people competed at this year's competition. Here are their scores. Okay, so there's 14 of these. Find the percentile rank for a score of 42. So remember the formula for percentile rank? Percentile rank is the number below the given score divided by the total number of scores times 100, but it's not a percent, it's a ranking. So it has to be a whole number because it's your position within the class. And it's always rounded up. All right, so let's just check to make sure everything's in order, and they are ordered from small to big. Okay, for a score of 42, well, here's the 42, right? There's 3 of them, but this is the first one. So B equals, there's 3 scores below 42, so B equals 3. And N, of course, equals 14. So the percentile rank is 3 divided by 14 times 100. And I get 21.4. As long as I have any digit after the dot, like even if it's a 0.0001, percentile rank always gets bumped up. So I have percentile rank of 22. Let's try percentile rank of 48. Okay, well, these are all the numbers below. So this time I have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. So percentile rank equals 11 over 14. Whoops. So I get 78.57. So that immediately gets bumped up to 79. So you can see that this person, whoever got the 42, is ranked 22nd in class, like 22nd, if you want to just be really, this is a music competition, I guess 22nd most talented, or like the 22nd from the bottom. This is 79th from the bottom, so this is near the top, right? This is a more talented student. Sam just found out that he scored 27% on a math pretest and ranked in the 80th percentile. Explain how this can be possible. Well, percentile rank has nothing to do with the score. With a person's actual score. It only tells where the person ranks in the class in terms of comparing to other students. So therefore, Sam has a top mark in this class. This means that 80% of the students' marks are below his. Okay, is it possible for 80% of the marks to be below 27%? Yeah, there's a couple things going on. Maybe this was a super, super hard test, pre-test. Maybe no one else studied. Maybe no one studied and Sam's kind of naturally gifted and managed to pull off a 27%. This may mean that the test, the pre-test, was very difficult, or that most students were unprepared for it. So you can see that Sam had a really bad mark, right? He had 27% is not good, but he's still one of the top students. We don't know why this happened. So all we can do is make some comments on possible reasons for this. Like, a possible reason is that it was a really tough test. A possible reason is that maybe it was an unfair test. The teacher might have asked them a whole bunch of questions they've never even learned. It could be that no one studied, right? There's lots of reasons. We don't know why. All we know is that he's a top student in the class. Okay, that is it for the unit. And hopefully you can look over this review and practice a little more. When you're ready to write the test, let me know. We'll start probability tomorrow and we'll just kind of keep chugging along, but I want everyone else to work at their own steam. So you write the tests when you're ready. And I'm going to sign off now, and then Tim, I'll hop on email and I'll email you right away. Okay.